Welcome to Reality Check, the Sci Fi London podcast. I'm Chris Patmore, Sci Fi London's online editor, and I've hijacked the show to bring you two interviews that will be reality checks. As most people know, good science fiction needs good science as much as it needs good fiction. In this podcast, we speak with a quantum physicist and a psychologist and discuss the science and ideas behind two different TV shows that are out now on DVD. First up, we speak with David Deutsch, a Fellow of the Royal Society and a quantum physicist at the University of Oxford. We speak to him about the parallel worlds portrayed in Fringe and the forthcoming indie film Another Earth.
The parallel universes, are they metaphysics or quantum physics, or just an imaginary thing of academics?
This is something that's highly controversial among quantum physicists, and I belong to a minority faction that believes that the parallel universes are an unavoidable consequence of both quantum theory and the experiments that support quantum theory, and so that they are in fact real.
Right. Would you care to expand on that a little?
Yes. There are various experiments that one can perform in the laboratory, typically the two-slit experiment, and that go under the general heading of interference experiments. What happens in these experiments is that typically something or other can go in two or more different directions, or something can happen in two or more different ways. Typically, a photon hits a semi-silvered mirror and it can either go straight through or bounce off, just a single photon. And the conventional interpretation of quantum mechanics is that when this happens, the photon has a probability of 1/2 of going straight through and a probability of 1/2 of bouncing off. Which means that there's still only one photon at the end. There's only one instance of what happens, and it's either the bouncing off instance or the going straight through instance.
So either it will or it won't.
It either will or it won't, exactly. Yeah. But in an interference experiment, you can subsequently do things to the two paths, to those two possible paths, bring the two paths together, and then what happens then is an interaction called an interference phenomenon, where what happens at the end depends on what was on both of those two paths. So like if you put a piece of glass or another mirror or something else onto either of those two paths, the net effect depends on what happens on both of them. And that means that something has gone round both of the paths, even though there was only one photon. And so, the obvious interpretation of that is that the photon just splits into two smaller things, mini photons or something. It's not really a single particle, and we're used to that kind of thing happening. And so it splits into two smaller things, and they go round, and then they rejoin themselves into a photon at the end. But the trouble is, you can rule that out. You can rule that possibility out by putting interpolating photon detectors onto the two paths, and you find that only one of them ever fires. If you shoot in one photon, then only one of the two paths ever detects a photon. And so, and it's a whole photon with the entire energy, angular momentum, everything that the original photon had. So that rules out that it's split into two. So there's only one of them there, and yet what happens at the end depends on what happened on both paths. And these paths can be separated by great distances, many trillions of times the size of the photon. So that tells you that this is a sort of, on the face of it, a contradiction. The photon is only in one place, but it somehow sniffs out what's happening at two or more distant locations, where some of which it might have been, as it were. And then, at this point, in my opinion, and I have to stress again that this is a minority opinion, at this point, the majority of physicists start talking nonsense. and say things like it's both spread out and localized at the same time, or that what actually happens to the photon depends on what could possibly have happened to it. But in my opinion, real events can't be caused by possible events. They can only be caused by other real events. And that leads eventually, I've oversimplified the argument here, but that leads eventually and inexorably to the conclusion that both events happen, but they can't see each other except in these rare circumstances of interference experiments. And so the photon, there were actually two photons in two different universes that normally don't see each other at all, but in these special circumstances do affect each other. And the same phenomenon has been demonstrated for not only for photons, but for material particles and atoms and molecules. And since we are made of molecules and obey all the same equations as the photons, we can infer that the same is true of us, and that the universe that we see around us, stars, galaxies, everything, is just one such thing that exists in reality. It's a tiny sliver of a much larger entity that includes many universes. It's sometimes called the many universes interpretation, sometimes called the parallel universes interpretation, because the universes almost don't affect each other like parallel lines, but unlike parallel lines, they do slightly affect each other. Otherwise, we wouldn't have any evidence of their existence at all.
So, might take the example of Fringe, where
Yes.
the two universes have developed along different lines.
Yes. So the universes will certainly develop along different lines, sometimes radically different lines, because there are situations in which which are sometimes explored in the series Fringe and in other science fiction. There are situations where a small effect of a single particle, such as a cosmic ray striking, can and according to the multiverse theory, when a cosmic ray strikes the Earth, it strikes it at different places in different universes, and therefore sometimes someone is struck and gets cancer as a result and then dies and doesn't contribute to human history, and in another universe they survive, and so you can see how the knock-on effects of a single subatomic particle effect can make the two universes very different from each other.
Or basically what's known as the butterfly effect, I guess.
Yes, although it's funny you should mention the butterfly effect. This effect of this knock-on effect is much greater in classical physics than it is in quantum physics. So in classical physics, it's happening all the time. Butterflies flap their wings and it affects a storm on the other side of the world, and so on. Turns out that in quantum physics, the butterfly effect is much, much smaller. And really, the only ways in which universes that are slightly different become very different is through large amplification effects that are deliberate, not sort of accidental ones like in classical physics. Quantum universes remain close to each other as much as they can, and it's only when something like a deliberate action, or something like a person being dead and therefore not doing the things that he would have done, that kind of thing can make the universes diverge. But most of the time, random events do not make universes become very different. If they're slightly different, they remain slightly different, and that's that.
I guess a lot of it's also to do with microcosm and macrocosm, and
Yes.
where if I miss the bus or not, it's not going to have a huge effect on the rest of the world, but it may have a small effect on what goes on in my life.
That's right. Most of the time, a small effect will result in a small effect in real life and in quantum theory. Classical physics kind of misrepresented the nature of knock-on effects. So the classical picture is wrong, and in real life, these large knock-on effects are rare, but they do happen.
But if you look at the world of the mystics, I mean, they talk about almost parallel universes where there's sort of the reality we see, plus there's the reality with a big R. I mean, is this a similar line to what quantum physics is going along?
The mysticism and science differ in their method. Of course, sometimes fiction happens to produce a true answer. You know, Sherlock Holmes had a friend called Watson, and it could be that somewhere in the world, some people who've never read the Sherlock Holmes story name their child Sherlock Holmes, and another one names their child Watson, and they become friends, and so on. Now, that can happen accidentally, just because even a stopped clock is right twice a day, sort of thing. But that is not a case of Arthur Conan Doyle having correctly foretold these events, these namings that might have happened a century later. It's just a coincidence. And it's the similar thing with mysticism. Occasionally, mystical theories happen to hit some of the right answers, but that doesn't mean that they had the same knowledge as science does later, because those right answers are rare among their answers, among the mystical answers, because science is an error-correcting process. And science also says a lot of false things, but then corrects them. And then the corrected theory also has some deficiencies, which are then corrected, and so on. Myths don't change except by very gradual evolution over many centuries. And so they don't have error correction, and so they're basically stuck with their original mistakes forever. And so that's why mystical ways of thinking are full of errors and don't improve, whereas scientific thinking also has errors, but makes them fewer and fewer by improving.
Although a lot of mystics talk about absolute truth, where there is no error, there is just the absolute reality.
Yes, this is a philosophical mistake that science struggled to escape from during the early years of science, about 300 years ago, when you see, if you believe in absolute truth, and then you're going to believe that you have some. And if you have some, then that leads you to judge people who disagree with you in rather harsh ways. You know, they are people who don't have the absolute truth. And if they do something that you think is absolutely wrong, you're going to feel entitled to suppress their idea. And the practice of science is the practice of not doing that, the practice of being open to criticism, because one expects one's own ideas to be mistaken in some unknown ways. Even if they're largely right, one expects that there are unknown errors in our ways of looking at things, and that, in fact, all our ignorance of the world, the things that we don't yet know, whether the Higgs boson exists and whether the universe will tear itself apart at the end of time, all those things are due to misconceptions that we currently have about what the laws of physics are and how the universe is set up. So the progress of science depends on certain values of science, such as tolerance and truth-seeking and fallibilism, the belief that one can be mistaken. Whereas the values that stem from a belief in absolute truth are, of absolute knowledge. Absolute truth is a perfectly harmless and, in fact, good concept. But the idea that one can know it, that there's a way of knowing absolute truth, is a path to intolerance and to error.
Because I have an interest in Vedic philosophy, and a lot of the stuff they talk about there is, I mean, the really in-depth stuff is coming around as also being exposed in quantum physics. I mean,
Yeah,
a lot of the time they're talking about the same thing, but in different languages, so to speak.
I fear not. The thing is, when you look at some scientific idea and then compare it with mystical text with the benefit of hindsight, then you can always see the parallels, just like in these experiments where they hand out horoscopes to people and ask them whether the horoscope matches their life, matches a description of them, and they will, with much greater much greater probability than chance itself would allow, they will say the horoscope does match them and does describe them correctly, even if the horoscopes were handed out randomly to the sample of people. And this is due to the human mind's desire to impose order on the world, to see patterns in the world. This is what makes us human. This is the thing we do better than any other animal, but it is error prone. And if you apply that ability without also applying the hard-won methods of science to weed out the inherent tendency to error in that very ability, then you will just see patterns where there aren't any. And with the benefit of hindsight, a lot of things look like quantum mechanics. But with the benefit of foresight, none of those worldviews that claim now, with the benefit of hindsight, to be like quantum mechanics, predicted a single one of the amazing experimental outcomes of quantum mechanics. And that has got to be the test, because without that test, we already tried being not having science, and for hundreds of thousands of years, our species discovered nothing, and has only discovered new things since we applied this error-correcting process of not just looking for patterns, but looking for patterns and applying methods that can get rid of errors that look true.
So, would you say that, in a way, I mean, this is going more into philosophy than physics, that we all actually live in parallel worlds because we have the reality that we perceive and the reality of the world around us, which is sort of what you were just saying now. You look back on things with hindsight and you can analyze them in that way.
Yes, I think I agree. I'm not entirely sure I understand what you just said, but
we have an opinion of ourselves and our vision of the world, and yet someone else has another vision of the world, but it's still the same world.
Ah, right. I see. Okay, so
we live at our world, but there's another world, but they could be perceived as parallel universes.
I understand. Yes. So, because we're fallible, the world as we see it is not the same as the actual world. There is such a thing as the actual world, but what we see is only an interpretation of it that is bound to have lots of discrepancies from the real one. Now, there is also another world, a parallel world, which looks much more like the one that we perceive. So in a way, our mistake happens to match up with the real thing. Just like in the imaginary story I told, a fictional story might accidentally match up with a real event. And even though the author thought he was writing fiction, in fact, it was a true account of a real event elsewhere on Earth or at a different time. And similarly, it will always be true that a fictional event that makes sense will be a real event in some other universe. So that is true. However, again, just as with the fiction, that does not mean that when we perceive that happening, we are accurately perceiving the other world. Because, as I just said, it's bound to be true. If what we see makes sense at all, it's bound to be true that it exists in another world. That doesn't mean we've perceived the other world. It just means we've imagined it.
Mm. Going back to the mystics again, I mean, the mystics talk about seeing the world as nothing more than vibrations.
Yes.
Which, I mean, does sort of correspond to what quantum physics is talking about in a way, doesn't it?
Well, again, only with hindsight, I'm afraid. For example,
also, we got no proof of what they actually saw.
well, yes, quite. And if they had seen something, they could have made some startling predictions, which would, for example, if we look at early physics of the ancient Greeks or the Arabs in the Golden Age, we can sometimes find that they surprisingly did have some scientific knowledge that we thought had only been invented much later. But in those cases, this knowledge led them to make a prediction which was surprising, and that prediction is borne out. And if anybody had known the truth of quantum theory before the 1920s, they would have easily made predictions that are absolutely startling. So, and they didn't. And so when they speak of, for example, vibrations is a very good example. Vibrations is a phrase that could mean, isn't used in fundamental physics. It's only used for engineering type applications of physics, and regarded as denoting something in fundamental physics. It could be a lot of things, and it could be waves. And there are interpretations of quantum mechanics in which particles are waves, and in
waves of energy.
Yeah, particle wave duality. Unfortunately, from my perspective, particle wave duality is part of the equivocation and nonsense that was talked by the early pioneers of quantum theory in an attempt to avoid the parallel universe's implications. And in fact, there is no particle wave duality. What the wave is not a vibration in anything. It's the extended nature of a wave that they were talking about, not its change going up and down like a vibration. It's just the fact that it's in more than one place at a time. And the more than one place at a time in reality translates into being in different places in different universes, not to moving from one to the other in a vibratory way. So if somebody had understood the parallel universe's implication of quantum mechanics somehow before the 1920s, vibration would have been the last word they would have used. They would have denied that quantum theory has anything to do with vibrations. They do use a word nowadays, fluctuations, which is likewise very misleading. Fluctuations is another of these double talk words that pretends that objects kind of go from one to the other very rapidly. But there's no such process described by the equations. What the equations describe is existing in both places at once.
Well, I guess one of the things that hampers all this is actual language. I mean, it's you asked someone to describe God,
Yes.
which lots of scientists have issues with anyway. But how can you describe something as immense as that? It's you're trying to bring something down into words that cannot be explained almost.
Well,
and I guess that this is an issue that you also scientists face, is you're trying to explain something. Whenever you give it a name, it is, but it isn't at the same time.
The thing is, science is hard to understand, hard to explain, and hard to test. But tests are possible. And when you have a weird theory that says that the world is very different from what our intuition and our apparent experience seems to say, what science does is, in the process of sharpening that idea, correcting the ambiguities in the idea, and correcting the errors in the idea, it eventually comes to a prediction. And that prediction is the opposite of all those things. It's the opposite of ambiguous. It is clear that everybody involved knows that if the spot of light falls on one place on the photographic plate or on the sensitive receiver, then the theory is true. And if it falls on the other place, then it's false. And the exciting thing that happens in science is that in some cases, these theories can make predictions that are absolutely amazing. The idea that the place where the single particle lands depends on what all the whole apparatus was doing, apparatus several meters across, so that something about that particle was probing that whole apparatus, is something that you can't see, is absolutely astounding. In my opinion, more astounding than any of the things imagined by mysticism or religion. So and we can understand them, and then somebody else can go away and say, well, if that's true, then this other amazing thing should happen. And lo and behold, it does happen. So, for example, well, we haven't actually verified this yet, but one of the predictions of quantum theory is that you can build computers that, using quantum theory, that are enormously faster than, for certain types of problem, a quantum computer could solve it faster than any classical computer, including one that was built of all the matter in the universe. So here's the experiment. You take all the matter in the universe, you build a computer out of it, you run that computer on this problem, and it takes a certain time to solve the problem. A simple quantum computer made of a few atoms could solve that problem in a microsecond.
And we all know the answer's 42.
Yeah, exactly. Yeah. No, but you can make it so that you can choose a problem such that the answer is easy to verify once you have it, but very hard to find in the first place. So even a normal computer can verify that it's the right answer, unlike in the case of deep thought and 42. What you do is what you would do is run this program, then verify it gave the right answer, and then that shows that some process produced that answer that was more complex than the entire visible universe, which means that there is more there than the entire visible universe. But it means something much more exciting than that. It means that this other stuff that is there in addition to the entire visible universe obeys equations that we know. We have knowledge that is so powerful and sophisticated that it can describe and predict and understand the motion of this entity that is trillions of times more complex than the entire universe, and we can harness it to do a little mathematical calculation for us. Now, that's something that was never guessed by any mysticism, but it has been predicted by quantum theory, and we're hoping to verify this in the next few decades. And also, if we fail to verify it, and if the answer comes out different, we will know that we were wrong, whereas that the theory was wrong. Whereas theories about mysticism are never exposed to this kind of danger of being proved wrong, and therefore when they are wrong, they just remain in their erroneous state. Attractive though they might be, but lots of attractive things are false.
There's a new film coming out soon called Another Earth. An identical planet Earth, complete with exactly the same people living on it, appears in the sky.
Right.
Complete with moon. And I mean, the story just, it seems to lack any scientific grounding whatsoever. I mean, the fact that if an identical planet Earth appeared visibly in our skyline, just the physical attraction of the two planets would create absolute chaos.
Yes.
And even the idea that these two planets were exactly the same and all the people on it lived exactly the same lives seems a little improbable to my mind.
Well, that couldn't happen in our universe. So they must be assuming that this planet came from another universe, which is contrary to the laws of quantum physics as we know them. But in science fiction, you could imagine, and that's what Fringe does. It imagines that the laws of physics are slightly different from what we know them to be, from what we believe them to be, which, after all, is perfectly allowed by science. You know, we expect our opinion about what the laws of physics are to be slightly wrong. So that's a legitimate piece of science fiction there.
This is the thing with science fiction. Even if you make up the science, you've got to make the science sound plausible.
Yes, now that's a very important point. And in my book, The Beginning of Infinity, when I discussed parallel universes, I also discussed the issue of what is the difference between fiction and fictional science and other universes, because they all overlap in conceptually, those things. And one of the things is that the fictional science has to make sense in its own terms. So that's and I try to explain the multiverse theory in my book in terms of a fictional story first. I start with the fictional story about parallel universes, and then I point out that this doesn't make sense in certain ways. So we fix it, and we get a better theory of, and so on, and we eventually end up with the actual theory of quantum parallel universes. I'm afraid I don't know about the film you spoke about, but there was a film a few years ago called Sliding Doors.
Oh, yeah.
Also about parallel universes. And that one, rather interestingly, it was a sort of tour de force, I thought, because it managed to have an interesting story about parallel universes that do not, in fact, interact with each other. So that story was perfectly consistent with existing quantum mechanics. Such things do happen in reality. And making a story about them is a terrific challenge, and I thought they did it very well. And they also showed how the butterfly effect isn't right. The things which become different as a result of a small change in these two universes are all human-mediated things, and that is exactly what would happen, what does happen in the real multiverse all the time. I thought it was a brilliant film.
It is a concept that's been used quite a lot in science fiction films. And there's also a film called Primer that came out a few years ago. I don't know if you've seen that.
That I didn't see, no.
But that was more to do with time travel, and these guys built a machine that could you could only travel forward 10 minutes.
Ah, yes.
But they ended up with 4 or 5 different versions of themselves.
Ah,
and
yes.
they had to keep watching themselves to make sure that they didn't do something else, and it's
that's interesting, because the theory of time travel and the theory of if time travel is possible, that's the same kind of variant theory of quantum mechanics as the theory that travel between universes is possible. The science fiction stories that are imagining contact between different universes, like Fringe, are imagining the same kind of variant physics, laws of physics, as the stories that imagine time travel. So and we can't rule that out. We can't absolutely rule out the existence of such things at the moment. What we can say, though, is that if time travel is possible, time travel into the past is possible, then it necessarily also involves travel into other universes. You can't necessarily make yourself go to an earlier point in your own universe. If you go to an earlier point, it is in general to that of another universe, and that's what avoids the paradoxes. So although you can end up with multiple copies of yourself, what you can't end up with is a paradox where you prevent yourself from setting out in the first place.
Yeah.
Or killing your grandfather. I don't know why the paradigm of this paradox is killing your grandfather. Nothing so violent is required. All you have to do is set up an experiment where you agree that if you appear out of the time machine, you're not going to go in it during that experiment. And that's a simple paradox in itself.
Yeah.
If you apply quantum theory to this paradox, you find that indeed you cannot go to the laws of quantum physics prevent you from going to the past of your own universe, but they do not prevent you from going to the past of other universes. And what happens then is that some universes end up with 2 or more copies of you, and in some universes, you've gone into a time machine and never came back.
Yeah.
So
yeah, I love time travel movies because they can just really mess up your head, basically.
Yeah, well, most of them, unfortunately, do not bother with making sense. And
Yeah.
I don't like science fiction that doesn't make sense.
Exactly.
I don't mind if they imagine different laws of physics. In fact, I like that. That's the good thing about science fiction. But and I think Fringe, for example, although sometimes it's deliberately silly, I think a lot of the episodes are kind of joke episodes, as it were.
Yeah, yeah. Well, they did the same with X-Files as well.
Well, X-Files was I think that was a case of really not trying to make sense, I'm afraid. But the basic storyline of Fringe, if you neglect the sort of joke episode aspects, really are trying to make sense and do quite nicely explore the issues that arise out of taking seriously the existence of multiple copies, which one is you, which one is the real you? Does it make sense to ask which one is the real you? And if you have the same thoughts and the same feelings and fall in love with the same people, are you really any different from each other? And they slightly simplify the problem, at least in the episodes I've seen. I haven't seen all the episodes, but in the episodes I've seen, there are only 2 parallel universes. But in real life, there are enormous numbers of them.
Mm.
So practically anything you can imagine that makes sense happens in some universe or other.
Because going back to the time travel, I mean,
Yes.
one could say that actually time doesn't exist because there is only the present.
Yes, well, that's a mistake. The physics, at least according to physics, physics doesn't distinguish between the present and any other time. So what the present is a perspective on the multiverse. And in fact, the different times are just different universes. They happen to be the ones that physics allows us to know more about by direct observation. There are countless other ones that are much harder to see, that we see only through their indirect effects via interference phenomena. And the past and the future are just the names that we give to parallel universes that we have much more direct evidence of and interaction with. The difference between different nows, different present times, is the same thing as the difference between different perspectives in space. So if you imagine the different copies of you of different times, they're rather like different people standing around a monument, looking at it from different angles. And in space, we can see them all at once, so we're not tempted to say that one of them is real and the other one isn't. But in fact, in time, they are all real in exactly the same sense that all the parallel universes of quantum theory are real. The past, the present, and the future are all real. When we say that, one's mind immediately jumps to the mistake of thinking, oh, well, if they're real, they're all real at the same time. No, that isn't true. They're not all real at the same time, because they're all different times. So that would be rather like saying that all those observers of the monument are all real at the same angle. No, they're not. They're all real at different angles. All the different angles are real. All the different perspectives on the monument are real perspectives, but none of them is the monument. The monument contains all the perspectives. The actual three-dimensional object determines all the perspectives and all the different perceptions of it. Same with time.
Someone told me once that we talked about aliens, and they said aliens exist, but only in the future.
I'm not sure what he might have meant by that. Did he mean that we are going to become the aliens as we spread out?
Well, I think it means that, like you said, with all these different parallel universes, if people see them, they're seeing something that's if they see aliens, they're not seeing them in this actual present day. They're seeing something that's leaked through from a future
I see. Well, of course, there's no evidence that anything can leak through from the future. And as I said, if it did, that would be uh, that would have massive implications for parallel universes because it would always leak through into another universe. If we saw an alien coming out of a time machine, that alien would have come from a universe that isn't our future.
Yeah,
So
I
the
guess
only
so.
reason that we might believe that there would be aliens in our future is if we also had reason to believe that the alien came from a universe that was very like ours, which we might have. We might have such evidence. But again, this is all different from the question of whether there are aliens out there, because whether there are aliens out there is a question that's open to experimental testing. A few hundred years ago, people imagined that there might be, or less than that, even 100 years ago, people imagined that there might be civilizations on the moon, or perhaps on the far side of the moon, which we can never see from Earth. And that was then tested because we can now look at high-resolution photographs of the far side of the moon on Google Earth. You can actually look for yourself and see whether there are any cities there, and there aren't. So that theory was tested, and science made progress. So 100 years ago, we did not know this, and now we do know it.
It's just like Nikola Tesla was convinced that there was life on Mars.
Was it Tesla? Yes. I mean, I know that Lowell, the astronomer, was convinced of that. And by the way, the history of Mars astronomy is a very good example of the ability of humans to see patterns when they aren't there, because different astronomers all saw these canals on Mars. And actually, the canals are just an artifact of what happens when you stare very hard at something and expect a pattern to be there. And if it's just at the limit of what your eye can resolve, your brain inserts the pattern. It's not a matter of fraud or anything like that. It's just a matter of the ability of the brain to see patterns, which is absolutely crucial in our discovering real patterns. But far more often than real patterns, it sees things that aren't there at all. And the method of science is to find ways of systematically eliminating the majority of perceptions which are of things that aren't there at all, and finding the ones that are there, testing that, and then going with that idea, which itself is usually flawed in some other way, but in that way we get more and more knowledge. This is the thing that methods of proceeding with knowledge other than science don't do. They don't correct their errors.
Excellent.
So good. Well, it's very enjoyable. Thanks for the conversation. I appreciate it.
Thank you. It's it's pretty much blown my mind for the rest of the day.
Fringe Season 3 is out now on DVD. Now we speak with Dr. Patrick Lehman, a psychologist from Royal Holloway, University of London, and an expert in conspiracy theories, such as those portrayed in the TV series The Event. Well, let's start with The Event, because that's one of the more recent conspiracy theory TV shows that's been out.
Sure.
Do you think, there's lots of different types of conspiracy theories. I guess one of the more popular ones is the possibility of aliens existing. Is that one of the strands you prefer to follow, or is it the more political types of conspiracies?
I sort of research kind of the psychological basis of all different types of conspiracies. So something like the idea of aliens living amongst us is classic material for a conspiracy theory, because it kind of pushes all the right sorts of buttons in terms of having a sort of hidden, powerful, different group doing different sorts of things. And of course, in The Event, it's tied up with a load of perhaps concerns or beliefs about conspiracies in contemporary society, big government, those sorts of things, which all feed into this general sense of conspiracies going on in the world today.
Yeah, I guess also with aliens, it's a lot harder to prove their existence, whereas with political conspiracy theories, there is much more. It's much easier to prove that they do exist.
I suppose if you've got a green alien with bobbly eyes, then it's probably a bit easier. But there's also something that's more exotic about conspiracy theories involving aliens. And one thing that we need to have a really good conspiracy theory is it's very difficult to see a conspiracy theory if you feel like you're on the inside of that group. So we find so the psychological research shows that there's higher levels of belief amongst people who feel in some way disconnected from society. So people like people who are in sort of low economic groups, who are in sort of ethnic minority groups, they perhaps feel less of a connection to society, more on the outside of it, and that automatically gives higher levels of belief in conspiracy theories. And of course, with aliens, absolutely, this is a completely different group, completely alien group. So this is already fulfills that thing of being something sinister, something unknown, something shadowy, something that's very different from what we are. And so they're bound to be up to no good, if you see what I mean.
Yeah, but I guess also at the other extreme, you get people who are above average intelligence who also question everything that they see and hear and don't believe anything that they read in the papers.
Absolutely, and I think there's a lot of similarity between some of the real hardcore conspiracy theorists and what are many of the qualities of a really good journalist or a really good scientist. So sort of doggedly pursuing the truth, not taking no for an answer, not just saying yes to the easy questions. There's something very similar about that. The difference between a good journalist or a good scientist and a lot of the hardcore conspiracy theorists is that at some point there comes a sense in which you have to be objective about the truth and that you can be open to changing your mind. And sometimes some of the sort of dyed-in-the-wool conspiracy theorists don't see that. But it's kind of getting into a mindset which has a lot of very positive qualities. So some very bright people believing conspiracy theories. It's more actually kind of where you start out and what you're looking for that's important in your beliefs. Does that make sense?
Yeah, I have a motto that is question everything, doubt nothing.
Yep.
So
I think that's a really good motto to have. And there comes a point where you have to make judgments, though.
Yeah.
And if you're constantly questioning, constantly doubting, then you might run into problems. But also, there's quite a lot of people who have really strong beliefs in some conspiracy theories. Some conspiracies are absolutely true, of course, so it's right to pursue them. But sometimes if your belief in your conspiracy theory shuts you off to alternative explanations, that's a problem. Do you see what I mean?
Yeah, you can tend towards fanaticism and paranoia and all sorts of psychological problems.
Quite often I talk to colleagues who are researching in it, and they say, we'll try and look at the psychology behind it, and there's this sense in which they want to paint all conspiracy theorists, or even people who believe in conspiracy theories, as in some way psychologically problematized, or they've got some sort of underlying paranoia or delusional set of beliefs. But it's not as simple as that. There are conspiracies, and it's perfectly rational to believe in some of them. The question is an interesting one. Where do you draw the line? When do you say, hang on a minute, this probably was just a lone gunman, or this probably was just a drunk driver? They keep you guessing. They are the perfect thing to draw you in to want to investigate yourself. Like almost like detective things. There's something that draws them in, draws you in rather as a someone who's listening to the evidence and everything.
Yeah, I guess because they can't. It's very hard to disprove or prove them.
Absolutely, but we still crave the truth. Do you know what I mean?
Which we always should. I mean, the same thing could be said for religion. I mean, lots of people consider anybody that follows any sort of religion can be a crackpot as well, especially amongst academics.
Absolutely. And they're both a lot about faith and a lot about evidence as well. It's all sort of contestable. And you realise life is very uncertain and we don't like it. But on one level, we're fascinated by it as well. In the event, the idea that there's a sort of hidden group of people, that almost draws you into doing that sort of thing, to constantly questioning, to make you a little bit more uncertain about the world, because we do actually live in an uncertain world. We don't like to live in an uncertain world. We like certainty and predictability in what we do. But a really good TV show will draw you in to make you feel some of that tension, some of that uncertainty, some of that anxiety and excitement about not being so sure anymore. It kind of feeds on I suppose, the paranoia or feeds on our fears in a way that a lot of really, really classic good horrors do as well. So, yeah, absolutely. It's good. There's lots of good qualities in constantly questioning, constantly asking. There's something a bit different about conspiracy theories when they perhaps tip over the edge to not seeing a more balanced argument.
You know, one of the things I really like about conspiracy theories is the fact that they're a good grounding for really, really good fiction.
Yeah.
X-Files is a perfect example of it. But a lot of the time, you can believe everything that they talk about in that show. It's all plausible, and a lot of it has been quite heavily researched.
Absolutely, and there's, one of the things that's great about the really good conspiracy theories is that there's almost no better story. There's a mixture of creativeness in constructing the story. There's uncertainty. It can be developed in different ways. You can look at evidence and interpret it in different ways. And so there's kind of a sense in which the story can really develop in an interesting way, because there are some people involved in it who remain hidden. So there's a sense of discovery about something. There's also this sense of excitement because it's an important thing that you're discovering. So, yeah, there's something about the story to all conspiracies that almost automatically draws us in, and you sort of can't let it go. It's part of what it's the nature of it. That's kind of what inspires your investigation into it.
I guess one of the most popular ones at the moment would have to be, since it's just had its 10th anniversary, is the 9/11 and the Twin Towers.
Yeah.
With all the news coverage that was given to it, that also gives them a lot the conspiracy theorists a lot more fuel to work with as well, doesn't it?
Absolutely, and there's always in any big event like that, there's always going to be thousands and thousands, probably millions of different pieces of evidence relating to everything from the backgrounds of the hijackers to the construction of the buildings and the ways in which they collapsed. And with so much evidence, there's always going to be room for doubt, room to discuss and argue and debate it. And that, you're right, that kind of that possibility, the fact that even that information's there, fuels discussion, fuels alternative accounts. It's part of why a big event is very often associated with conspiracy theories. But some of my research looked at exactly that these big events seem to really draw conspiracy theories towards them for some reason, partly I think because we don't like having a very mundane explanation for them. It unsettles us. It makes us think that the world is a bit more uncertain.
And then there's the other theories all about the New World Order and the Bilderbergers and these people that are actually controlling the world. I mean, do you buy into any of these theories, or do you not actually have a personal interest in conspiracy theories, but just are more interested in studying people that look at the theories?
I do have a view on some of them, but I think from my research perspective, I do try and set that aside and just look at why people have the beliefs that they do. Because, of course, some of these theories might be true. People do conspire to do bad things, and sometimes sometimes they're successful, and sometimes these things happen. So, of course, some conspiracies are true, some are false, and sometimes, the evidence points towards something a bit more going on. But no, I try and set them aside and kind of focus on the question of why do people believe, and not try and second guess whether I think this one's a good one or whether Elvis really is still alive or all that sort of stuff. it's quite a good principle. Is that quite more often than not, it's probably cock up rather than conspiracy that explains what's gone on. But actually, you're right to keep questioning, because they do happen. Something like Watergate, no one would have ever have guessed this or found this out unless two journalists had really gone after the truth there, at some personal danger as well.
Well, so I guess all this social media is a good way. Must have really get conspiracy theories spreading a lot quicker than they would have in the old days.
Well, the first one that really went, well, it wasn't sort of social media, but the first one that really went was the Diana one, where there was a conspiracy website within about an hour of her dying. Some guy in Australia had set up a conspiracy website already then. And he was in Australia, and I don't know how he could quite have found out about all the details of the crash, but that suddenly it catches like wildfire. There's communities for sort of people, like-minded people, to get together to like confirm their own evaluation of the evidence. So there's lots of good things about social media, and yeah, I suppose it's good to communicate and good to share ideas, but there's just more opportunity for these things to grow, I think. Yeah,
and also make people look ridiculous, because some people do end up looking quite ridiculous with their theories as well.
They do, but they believe them the levels of certainty about them are quite stunning. And if you look, I don't know if you, we'll have to look at The Truth Is Out There, that film, but I think the interesting stuff comes when you start challenging people on both sides of the argument. If you had a sort of interview and challenged a conspiracy theorist, but also challenged someone who was really dead certain that, for example, JFK was just assassinated by a lone gunman. There was no conspiracy or anything else, As soon as you challenge people, you start questioning their certainty, and they either don't like it or they suddenly get made more uncertain. So,
the first and only season of The Event is out now on DVD.